Voyager 1 just made contact with a highly advanced object in space. A lot of people have a good understanding of how the universe functions, with a lot of knowledge based on guesswork and speculations. But what happens when this information contains a terrible warning that alters everything we previously believed to be true about the universe? This is Voyager 1 just made contact with a highly advanced object in space. The Voyager missions have been at the forefront of space exploration for almost 50 years, offering priceless insights into the secrets of our solar system. Given the abundance of data these missions have produced, it is difficult to imagine that they were ever meant to last this long. The tale of the Voyager program is fascinating. Michael Minovich made the accidental discovery that a spaceship might use a planet's gravity to slingshot further into space, which set the whole thing in motion. In order to investigate Jupiter and Saturn, this prompted the 1977 launches of Voyager 1 and Voyager 2. In order to change their orientation and point their radio dishes toward Earth, both Voyagers have 16 thrusters and 3.7-meter radio dishes. Their thermoelectric generators run on plutonium fuel, while their engines are powered by hydrazine fuel. Both carry a total of 11 scientific instruments, half of which were intended for planet-related research and are now turned off. Today, the grand tour of the 4 planets is recognized as a significant achievement in human exploration. Voyager 2 completed the first-ever close studies of Uranus in 1986 and Neptune in 1989, while Voyager 1 passed Voyager 2 a few months after launch, passing Jupiter in 1979 and Saturn in 1980, and has become the furthest distant artificial object from Earth. While Voyager 1 said goodbye to our solar system and headed into interstellar space, Voyager 2 had some intriguing stops in store. In 1981, a corrective maneuver was performed to direct Voyager 2 toward Uranus. The spacecraft finally arrived at the isolated ice giant in January 1986 after exceeding its original estimated lifespan twice. Voyager 2 discovered 10 previously unknown moons on its journey to Uranus, adding to the increasing cosmic family. But the ultimate destination was Neptune, where Voyager 2 took almost 9,000 photos and discovered 9 previously unknown moons. But that wasn't all. Triton, Neptune's largest moon, had some intriguing secrets to reveal as well. Triton's diameter was discovered to be smaller than previously assumed, and the satellite had remarkably few impact spots on its surface. And what about its brown-white coloring? Geysers. When liquid nitrogen falls to the surface of these volcanic formations, it freezes into white nitrogen snow. The Voyager mission left a lasting mark on our understanding of our cosmic neighbors with these remarkable discoveries. After Voyager 2, no other spacecraft has returned to Uranus and Neptune. From afar, scientists have been able to see and study extraordinary events on these planets. Our solar system's ice giants are few and far between, with only 2 members, Uranus and Neptune. Despite the names, the majority of the material of these planets is not frozen, but rather consists of hot, supercritical fluids composed of volatile chemical components like water, ammonia, and methane. Uranus is the second most distant planet in our solar system, at an average solar distance of 1.8 billion miles, and its diameter is more than 4 times that of Earth. Uranus takes around 84 years to orbit the Sun, and during that time it appears to be lying on its side. Voyager 1 just made contact with a highly advanced object in space. The cause of this unique axis inclination is unknown, although scientists believe it was caused by a collision with a huge protoplanet early on. This could also explain Uranus's 27 moons, which may have developed from the crash debris. If that isn't enough to captivate your interest, the Hubble Space Telescope found a large white spot in Uranus's upper atmosphere roughly 10 years ago. It turned out to be a massive storm, swirling around at a speed of about 89 miles per hour and larger than the United States. But if you think that's extreme, consider the freezing temperatures of Uranus's methane and ammonia clouds, which may reach -323 degrees Fahrenheit. Remember that, like Saturn, Uranus has its own ring system, though it is considerably sparser and less abundant. Neptune. In 1846, a bluish glittering planet was placed into the star charts, and we called it Neptune. This planet is approximately 3 billion kilometers from the Sun, making it an outlier in our solar system. In comparison, the distance between Earth and the Sun is only roughly 90 million miles. Despite its distance, Neptune is similar in size to Uranus, the ice giant, with a circumference of 31,000 miles. In terms of mass, though, Neptune wins the cake with a staggering 17 Earth masses compared to Uranus's 14.5 Earth masses. Neptune takes a remarkable 165 years to round the Sun, yet it spins very swiftly on its axis, completing one rotation in only 16 hours. When NASA's Voyager 2 spacecraft visited Neptune in 1989, it caught some extraordinary weather phenomena, including sparkling bands of clouds in the atmosphere and storms reaching high speeds of up to 1,305 miles per hour, the fastest winds ever observed on any celestial body. Although scientists think that Neptune's lack of solar energy is what causes these storms to whip up to such amazing speeds, there is a risk that they might disappear one day. The Great Dark Spot, a gigantic structure the size of Eurasia that was thought to be a hole in the planet's visible cloud cover, was found by scientists during the Voyager 2 mission. One intriguing notion proposes that Uranus and Neptune are experiencing diamond rain. This hypothesis, which was previously only a thought experiment, was really established a few years ago by a team of researchers. The team simulated the intense pressure within the ice giants using polystyrene, a material comprised of hydrogen and carbon atoms. To test if the hydrocarbon compounds would break under such pressure, they administered 2 shockwaves through the substance. The experiment increased the thermometer to a searing 9,000 degrees Fahrenheit and produced a pressure of 1.5 million bars. Don Gurnett, a scholar at the University of Iowa who participated in the Voyager mission, claims that nobody knew how far away the heliopause was at the time the ship launched. Since Jupiter is just 5 times further from the Sun than Earth, some people hypothesized that it might be even closer. However, as Voyager traveled farther, estimations of the distance to the heliopause rose, eliminating Jupiter, Saturn, Uranus, and Neptune. The location and timing of the spacecraft's entry into interstellar space were unknown. Don Gurnett claims that immediately after Voyager passed by Neptune, it noticed heliopause indications in the distance. Many scientists were skeptical when Gurnett asserted that Voyager had discovered radio waves at the heliopause. These radio waves were not only unheard of, but Gurnett's interpretation of them also indicated that the heliopause was far from the Sun. In order to put this into perspective, consider that while the heliopause appeared to be far away, the distance between the Sun and Neptune is only 30 astronomical units. Despite these reservations, Voyager 1 crossed the heliopause successfully at a distance of 121.6 astronomical units, in line with Gurnett's prediction. However, NASA opted to postpone the disclosure of the achievement for more than a year due to the controversy surrounding the claim. Even though Voyager 1 did see some signs suggesting it had left the heliosphere, including a rise in cosmic rays from outside the solar system and a drop in high-energy solar particles, many scientists were still unconvinced. The abrupt rise in particle density that occurs while exiting the heliosphere cannot be measured due to Voyager's plasma instrument's malfunction, which is a problem. Beyond the heliosphere, it was anticipated that the magnetic field would point in a different direction, but this did not occur. Even now, researchers are still baffled by the phenomenon that causes the magnetic fields inside and outside the heliosphere to coincide. It's a riddle that hasn't been cleared up. However, Voyager's remarkable trip was partially made possible by the Sun's wild outbursts. Click on the subscribe button if you are finding this video interesting. Massive solar storms that occurred in 2012 jolted the plasma that Voyager 1 was through. As a result, the plasma's electrons started to dance and release radio waves that Voyager was able to detect. These waves' frequency revealed an intriguing fact. Voyager had just entered a denser part of space and was going to encounter some mind-blowing surprises. Voyager 1 has been an actual pioneer in the vastness of interstellar space, traveling for more than 10 years outside the magnetic field of our Sun. High-energy particles and cosmic radiation are hitting the craft from all sides in the hostile environment that exists outside. Despite these challenges, Voyager 1 has persisted and has provided crucial data and insights into the mysteries of deep space. Strange occurrences like the most recent AACS malfunction, according to Susan Dodd, the project manager for Voyager 1 and 2, are typical of this groundbreaking expedition. The Voyagers have completed 45 years of exploration and continue to stand as a testimony to the remarkable accomplishments of human ingenuity and tenacity. What do you think of the Voyager mission? Want to know more about Voyager 2? just made impossible discovery after 46 years in space. Watch this video popping on the screen right now to learn more.